2015 Senior External Physics Exam, Paper 2, Question 1. A mass is placed onto an inclined plane as shown below and allowed to slide freely. Neglecting friction, for what new value of theta would the acceleration down the plane be half its current value? Now, having read the question, we now need to identify and draw. So the forces that are acting on my block. Starting here, I have a reaction force perpendicular to the plane. That's at a right angle there. And I have a vertical weight force going straight down. Now my weight force is at an angle to the plane, and it's an angle in here to the vertical. It's an angle of 60 degrees, which is the same as the angle here. Now in this particular situation I need to sum my forces, so I'll sum my forces perpendicular to the plane, and summing the forces perpendicular to the plane should be 0. Vertically, I've got the reaction force upwards. This has got to be balanced out by the weight force perpendicular to the plane. So the weight force is this component here along this dotted line, W being the hypotenuse, 60 degrees being the angle, this component here being W cos 60. So R minus W cos of 60 is going to equal 0. So we can go through now, we can say, right, R equals W cos 60. Now I can also now sum my forces parallel to the plane. When you sum the forces parallel to the plane, that's the direction in which the block is going to slide. So that will be the resultant force on it, which will be mass times acceleration. The only part of the force which is acting down the plane is the component of the weight force which is parallel to the plane. The component of the weight force which is parallel to the plane is this component here, which is W sine 60. So W sine 60. Therefore, equating these, MA equals weight, which is mg, multiplied by sine of 60. I can go through now and I can cancel out my masses. So therefore my acceleration is g, which is 9.8, multiplied by the sine of 60. Sine 60 in my calculator. The acceleration down the plane will be 8.5 meters per second squared. Now, we are asked what would the acceleration down the plane for half its value. So what we're asked to calculate here is an acceleration of 8.5 divided by 2. So therefore, in the situation where after the angle, where the acceleration down the plane is equal to 4.25. So therefore we can go through and we can use the same equation here. A is equal to G sine theta. In this particular case we're looking for an angle, an acceleration of 4.25. G is 9.8. Now by sine theta, so sine theta divide both sides by 9.8 is 4.25 divided by 9.8. So sine theta is equal to 0.433. So therefore theta is the inverse sine of 0.433. So therefore the angle is 26 degrees. Does my answer make sense? I have an angle here of 60 degrees. As this angle here decreases, it's going to slide down with less acceleration. So yeah, an angle of 26 degrees will make sense.